And now for a thing that I'll call even more substitution examples. Let's say we want to say what the integral of secant squared of 4x plus 1 is dx. The first thing you should always think is, do I know whose derivative this is? And if you do, maybe you do. Maybe you can immediately say, oh, well, wait a second. Isn't it just tangent of 4x plus 1 plus c? Oh, wait a second. The derivative of tangent is secant squared, but the derivative of tangent of something is secant squared of that something times the derivative of the something. That's going to get a times 4 in there. So it's 1/4 tangent of 4x plus 1 plus c, and you're done. If you aren't comfortable about that, you set u equal to the stuff inside, 4x plus 1. du is 4 dx. So dx is 1/4 du, and then this becomes the integral of secant squared of u times 1/4 du. If you really want, you can put that 1/4 out and get secant squared of u du. And then hopefully you're like, oh, clearly the derivative of tangent is secant squared. 1/4 tangent of u plus c, and that is 1/4 tangent of 4x plus 1 plus c, which is what some people can just do right off the top of their heads. Yay! Let's try something a little bit trickier. Let's say someone says, what is the integral of 1/1 plus x squared dx? You say, well, I've got no parentheses, I've got no functions. Let's set u equal to the denominator, 1 plus x squared. du is 2x dx. So we can move the constant over. 1/2 du is x dx, which we don't have. See, we just don't have it. I mean, maybe you move the x over again. You can say, well, dx is 1/2x du. And so we get 1/u times 1/2x du. See, you can pull the 1/2 out front. 1/2, 1/ux du. Now this du says my derivative, the variable that we're using is u. This one's all right. That one is not all right. So what do you do? What you do is you say, does not work. And you have to try some other technique. And then you think, oh, duh. The arctangent of x, its derivative is 1/1 plus x squared, and then you're done. Ka-ching! And what else could we do? We could do something like the integral of e to the x minus 1 dx. And this is one of those set u equal to, well, it's an exponent, x minus 1, but you could also look at it. Some people even write e to the x as exp of x to make it look more functiony. It is a function, but I don't do that. Du is just dx, right? 1 dx. So this just becomes integral of e to the u du, which is e to the u plus c, which is e to the x minus 1 dx. No, not dx, plus c. Wow, that looked way too easy. Yeah, well, the derivative of e to the x minus 1 is e to the x minus 1 times the derivative of x minus 1, which is 1. And if you plug in plus c, it doesn't matter because that goes to 0. I think that's enough for now. I think we can start trying some of these in class.